Let's have a look at limits. You need to be able to identify the type of limit you would have to do and then know how to do that type of limit. The first type, we just substitute the value and we simplify. So if we have x approaching 3, wherever there's an x, we're going to substitute the value of 3. The moment I substitute, the limit symbol disappears. And wherever there's an x, I substitute the value of 3. And I simplify. 3 squared is 9, times 2 is 18, minus 3 is 15. Done. Next question. If h approaches 0, wherever there's an h, I'm going to substitute the value of 0. So the x stays x. Where there's an h, I substitute a 0. And now I simplify. Anything times 0 gives me a 0, minus 5, all done. If I attempt to do the same for the next type of limits, and I substitute x is 2, that will make the denominator 0, and I can't have that. So I need to make another plan. And that plan is to factorize. So you need to remember the methods of factorizing from earlier in the semester. I'm not substituting yet, so I keep the limit symbol. The numerator is a difference of 2 squares. So that's going to be a bracket x minus 2 and bracket x plus 2. The denominator is in the simplest form already. I can now cancel out those two brackets as they are exactly the same. So now I have the limit as x approaches 2 of x plus 2. No denominator, definitely no denominator of 0. Now I can just substitute the value. Wherever there's an x, I substitute a 2 and done. The third type. Now x is approaching infinity. I don't quite know how to substitute that. So I'm going to make another plan. That plan is to divide every term by the highest power. So if I look at this expression, the highest power I see there is x to the power of 2. So I keep the limit symbol because I'm not substituting any value yet. Every term, it starts very tedious and then it just simplifies beautifully at the end. Every term divided by x squared. 2x divided by x squared. 1 divided by x squared. And the same in the denominator. 3x squared divided by x squared. Negative 2 divided by x squared. Every term divided by x squared. Now I simplify. I'm still not substituting, so I keep the limit symbol. X squared divided by x squared is 1. Next term, x can cancel out with one of the other x's. So there's left negative 2 over x. This term cannot simplify any further. Now I simplify denominator. The two x squareds can cancel out. There's left only a 3. And 2 over x squared cannot simplify any further. Now I use a magic fact that I know. If I have x in the denominator, the bigger that x value gets, the smaller the overall value will get. Let's have a look. I have a half, the value is 0.5. A quarter, the value is 0.25. And you see the denominator is getting bigger and the decimal value goes down. So imagine if this denominator value approaches infinity, which is very big, then the overall value will approach 0. That's the fact that I'm going to use now. So I'm saying 2 over x, if that denominator approaches 0, approaches infinity, the overall value will approach 0. 1 over x squared, the denominator will be infinity squared, it will definitely approach 0. 3 will be 3. Negative 2 over x squared, if x approaches infinity, x squared will definitely approach 0. And voila, simplifies to 1 over 3. So there's the 3 different methods we use for limits. Know when to use each one, and then how to simplify that. We're now going to look at differentiation from first principles. Symbols, notation used for differentiation. If we differentiating f of x, the derivative can be shown with f dash x, or with d dx of fx, or dy dx. All of those mean the same thing. They all mean the derivative of the function f of x. And the formula from first principles for differentiation is that one. So we're going to do this one, differentiating fx is x squared from first principles. We're not going to do many of these type of calculations just because they're a bit tedious. We're going to learn the shortcut very soon. So if I want to do this, use this formula, I already know the value of f of x because that's x squared. So all I need to do now is find the value of fx plus h. So fx plus h means where there's an x in the function f of x, I'm going to substitute x plus h squared because it's x squared. I simplify that. That means the bracket times itself. And then I expand the brackets, and that will be x squared plus 2xh plus h squared. So then I also have the value for fx plus h. And now I'm going to substitute all of that into the limit, h approaching 0. Fx plus h is x squared plus 2x plus h minus fx is x squared. So I'm substituting into that formula. And h. This is xh, sorry. And h squared. X squared minus x squared is 0. So now I have the limit h approaching 0 of 2xh plus h squared. I can't just substitute h equals to 0 because that will give me a denominator equal to 0. And the plan we make is then to factorize. I take out h as a common factor. Those two cancel out. And now I can simplify. Where there's an h, I substitute a 0. So now I have that the derivative of fx is 2x. And the fx I started with is when fx is x squared. And next thing we're going to look how to get to this answer much quicker than this. But we have to understand where the first principles come from. And that's all for now.